Welcome to the another video of the Power Prince converter where we discuss the discontinuous conduction mode. So far we have already discussed about the continuous conduction mode and discontinuous conduction mode with constant VD. So here assume that the supply voltage is given through some AC to DC converter, and when we use AC to DC, so there is obviously a chance that input voltage VD is not a constant. So VD may be fluctuating. So VD here is not a provide fluctuates. So we don't have the output voltage. This VD voltage has constant value. So we need to regulate the output voltage V0. So we need to regulate the output voltage. So if V0 is maintained constant, in that case, how the value look like? So we know that we have ILB for the just continuous mode. What is the value of ILB? That is a breakdown. That is a boundary value. ILB means what is the inductor current, average inductor current for the boundary value. This is equal to TS V0. So we know that this value is equal to VD TS by 2L D1 minus D. So we can rewrite this VD into D as V0 TS by 2L 1 minus D, because now we are not taking the VD as constant, we are taking V0 as constant. So we are writing in terms of some constant values. So in this case, the value of ILB max will be different, because here ILB max will happen when D is equals to 0. Then we have the value of ILB max is V0 TS by 2L. So, and because we take the value of this derivative with respect to D, it will obviously come as 1. So that D equals to 0, obviously it will come at. So at D is equal to 0, we'll get this value. So this is the value of ILB max in case we are writing in terms of V0. So thus we can write here ILB is equal to, we can substitute this value and we can write this as ILB max in terms of 1 minus D. We are writing ILB in terms of ILB max. Just substituting this, we are getting ILB is equal to ILB max 1 minus D. Now we can get what is the average current. Here the average current is the I0 is the average current. That average current, we know it is equal to half IL peak into D plus del 1. How do we get? We can calculate here the average value of the current I0. We can say average current we can calculate like I0 into TS will be same as half base is D plus TS, D plus delta 1 TS into height. Height is del I, or you can say IL peak. So here TS cancel out. So here we can write, this implies I0 is equal to half IL peak into D plus del 1. So here I just rewrite the again entire thing. So how to get this IL peak? We know that we can use a formula VL is equal to L di by dt. So let us say the change in the current is IL peak. So what is the voltage is V0 into del 1 TS. So we rewrite like this, IL peak is equal to V0 into del I TS. V0 is the voltage of VL during this time. We can take any of this. V0 is the voltage, multiply with time duration, that is del 1 TS divided by L. So we return the value of IL peak into D plus del 1. So let us simplify this. So we can rewrite these values. You can say that I0 is equal to, so here this term is there, so this term can be replaced with ILB max. So we can write here this is as ILB max into del 1 d plus del 1. So this is the expression we get here again, and also we have V0 by Vd is also written as d by d plus del 1. This we have seen. So here we can substitute the value of d plus del 1 here, so that we can get a unique value of del 1 here. So we are getting this expression ILB, and del 1 we take it, and d plus del 1 we substitute the value d by V0 into capital D. So here our objective is to get the value of I0 by ILB max 1, and here del 1 will be there, and this will be multiplied with d divided by, so this will, let us say, V0 by Vd as together 1. So here also we can get the value of d. So we can get the value of here del 1 also. Del 1 is equal to this multiply of I0 by ILB max into V0 by Vd whole into 1 by d. This is the value of del 1. So we just need to put the value of del 1 here. So in this expression we can get V0 by Vd is equal to d by d plus, this del 1 expression will be I0 by ILB max into V0 by Vd into 1 by d. So this d will be like, we can take it up, d square plus, this is the multiplication of two terms, the V0 by Vd and I0 by ILB max. So we can do this some mathematical changes over here, just multiply these things and get, and finally we can get from here, so we just rewrite this equation here like cross multiplication with d square, another is this term square, because this V0 by Vd and V0 by Vd will multiply each other and square, getting this term. And we can take this d square on this side and say this minus 1 d square is equal to this, and that gives us the final expression now, that we take a d square is equals to V0 by Vd whole square into I0 by ILB max divided by this term, because since we are writing this term in the right hand side, so this will interchange 1 minus V0 by Vd, that's a value, and this we can take together common, and we can write like this. So here where expression of d is equal to V0 by Vd, I0 by ILB max whole divided by 1 minus V0 by Vd. So that we get an expression of the duty cycle, so that we can keep the value of this V0 constant. So objective is to keep the value of V0 constant, change the value of the d. So if V0 is constant, assume, so if Vd is changed, this Vd is changed because of the load current. So to keep this value, we can get the value from all this expression, we can calculate what is the value of d, your duty cycle. So the duty ratio d can be written in the function of I0 by ILB max, okay, for various value of Vd by V0, keeping V0 constant. So let us draw that curve. Now in this curve, in the x-axis we have I0 by ILB max. Now we have this ratio of V0 by Vd. Let us write here Vd by V0, because V0 is assumed to be constant, Vd is varying. So for a fixed value of Vd by V0, so let us fix it. So if I fix this value, so if this value of I0 by ILB is increasing, and so I'm getting a direct relation. It is like initially there is some variation is there, otherwise it is I0 by ALV. It is changing. So here when you have, so you are getting one term is missed over here. This is 1 by 2 because this is square root of the term. So here after getting root over a term, so here y is equal to, these are the constants, so you have a root over of x. So you will get a term like this for a particular value of Vd by V0 is equal to, let us say, 5. And again, if you try to be close, then you get Vd by V0 is equal to 2. So, and again, if these two are equal, so we get the value of Vd by V0 is equal to 1.25. So if Vd is very high, so we have to keep the duty cycle low, nearly around 0.25. Let's say this is 0.5, and let us say this is 0.75, and let us say this is 1. So we have like for a different value of Vd d, so we can get a slope like this, and this intersection point is say 1 here, and this is also 1, and this is how the current, output current, is increased, and we can get a, now this is a curve, this is the step down converter, the characteristics keeping V0 as constant. So when you keep V0 constant and your Vd is very close to V0, the duty cycle is nearly 0.75, and gradually if the differences increase, so duty cycle has to decrease. In this way you can get this curve. So thank you.